So when I picked the presenter for December, I thought I picked a very good topic and a very good presenter. There were some objections, but we passed over them. That very good presenter is Jerry McGann, who is the inaugural president of FEZOS, FEZ-WA, at that time, and he was a joint finder. He had, I haven't counted there, maybe more than 30 years contribution to FEZOS.
Yeah, Jerry's been around for 35 years, and he's a very well-respected lecturer and skilled technician in petrophysics and oil and gas.
So thanks for turning up for this Christmas talk, ladies and gentlemen. So as Adrian said, I was asked some months ago if I'd give a talk, and the topic was about climate change, and I thought that was a bit specific. And so I'm going to talk more about the challenges to our industry, specifically in Australia, and climate change is one of those that we'll get to towards the end. So I'm going to talk about liquids first, and then gaseous products second, and then a little bit about reservoir evaluation. Many of you are in that industry. And then we'll talk a little bit about climate change and how that will impact our illustrious industry of oil and gas. So let's talk about oil at first. Many of you would not be aware that the Saudis have been attacked 7 times in the last 4 months, basically by Iran. And am I using a mouse? Yeah, or just a finger? Okay. So Sheba here, 1 million barrels a day of light sweet Cretaceous crude, was attacked with 10 drones just in August. Didn't really hit the press. And of course, Abqaiq up in here, exporting 5.5 million barrels a day, did hit the press, and a massive attack with drones and cruise missiles from Iran. And of course, the ships that were also basically captured by the Iranians. And for all of that, and with OPEC cutting back production here, you can see in the middle graph, we see, and in the left-hand slide, very little excess capacity from anyone except the Saudis. The Emiratis have a tiny bit, and the Iranians can't basically give their oil away at the moment because of the US sanctions. For all of that, we see the forward strip of oil and gas after the attacks on Abqaiq basically doing nothing. We can see that through 23, the projected oil price is still about $50, $52. So to me, all of that doesn't quite ring true, you know, that I think we're probably going to look, and I hope we are going to look at slightly higher oil prices in the coming couple of years. US is obviously the price maker these days. They've gone from, can we get that on the screen probably, Nigel? They've gone from 12 million barrels a day to 12.9 in the last 3 weeks. This is unprecedented in our industry, of course. And this slide is a kind of slightly complex one. These are individual basins, and but I draw your attention to the right-hand graph and these little yellow dots. And these are the annual decline of the oil wells in the States. And you can see they're up to 35% now. So they've touched 35% way back in 2014, but they've climbed to that number again. So we see a situation where in these unconventionals you have to keep drilling, and your well has to pay out in that first year, otherwise it's really fallen off a bit of a cliff, especially with $55 oil. And we've seen again in the States a whole lot of things happening. There's about 220 rigs not working compared with 12 months ago. We've seen private equity basically backing out of funding unconventionals. So this is now pretty much a big boys game. You saw the Occidental takeover of Anadarko probably for 57 billion, was it? I reckon, and what do I know, that, you know, the US production will kind of flatten out at 13.5 million barrels a day. Still an awful lot compared with where they were just 5 or 6 years ago. And of course, all of that in the environment internationally, where we've had underinvestment in Africa and the North Sea and in all kinds of other producing basins since 2008, since the GFC. So it's a rather confusing world, but there's going to be an awful lot changing basically in the US. Looking closer to home, you'd all be aware of this, but the average taxi driver or whatever Uber driver these days will say that Australia is self-sufficient in oil. It ain't necessarily so, and it certainly isn't true except for these 15-odd years. So this is an ever-widening gap. We produce 270,000 barrels a day on a good day, and we consume 1.1 million. This is the largest import over the last 10 years, some $30 billion a year, and of course it's only going one way. Does it ever get talked in Parliament or amongst our politicians these days? Not really, no. So you add to that our strategic position in terms of liquid hydrocarbons, and we only have 22 days on a good day of oil onshore Australia. We have virtually no Australian flagged tankers. Even Singapore has 50 days of strategic supplies. They've buried or tunnelled that underground over the last 12 or 13 years. And here we are, we have 20 days if we're lucky. So I think one of the areas that we'll see a lot more investment in the next 5 to 10 years and a lot more acknowledgement is subterranean storage in depleted reservoirs, and also a whole bunch of floating tankers sitting off our coast available when the manure might well hit the fan in this crazy world that we live in. So let's kind of look at gas, turning to gaseous molecules. Again, things have changed a lot in the last few years. Qatar has obviously increased its production, but again, the real game changer here is the US. Australia produces about 8 BCF a day. It's hard to get the exact figures, maybe 9 on a good day. And we export about 7 and change, maybe 8 on a good day. The US has gone 3 years ago from exporting 0 LNG. They exported gas, of course, pipeline to Mexico, to now about 6.5. They're building LNG trains for 5 million. It's a 5 billion, obviously, a train. It'd be nice if it was 5 million. Compare that with Gorgon, and you know the numbers there. A lot of the infrastructure, pipelines, channels, jetties, all of that kind of stuff is in place. They're coming on stream as we speak, and within 18 months, the US will be exporting more LNG than Australia. This is being exported from the Gulf Coast through the relatively new Big Panama Canal. And these are big ships. These are 210,000 cubic metres. They're bigger than anything that goes from the Burrup. LNG powered, they do 28 knots. So their transit time from the Gulf Coast to East Asia is not that much more than from the Burrup, or from Queensland. So this is really changing the spot price situation, and it has a lot of LNG managers in Australia a little nervous, I would think. One of the reasons why they can export gas very cheaply and effectively from the US is the feedstock price. There's an abundance of gas coming from the Permian Basin, the Eagle Ford, and you're lucky if you can get $1.97 for an MCF of gas these days. Some people from the Canada-US border are basically giving it away. It's very hard to find the retail prices of gas in Australia. This is Australian dollars, obviously, but certainly the trend is going up. Most people are talking about $8, $9 Aussie for feedstock, and of course that's before you liquefy it, export it, or anything else. So the trend is only going one way in the States. Gas prices coming down, and in Australia it's going the other way. So it's a bit of a concern. So jumping now to formation evaluation, that's really what this society was formed for all those years ago by Hugh Crocker and myself. Incidentally, Hugh's in hospital. He's had a minor stroke. Some of you would know Hugh, of course, but he's doing very well apparently. So we can see the share price with the GFC, a little bit of recovery, and then 2016 and low oil prices whacking the share price of the major contractors. This is what's happening in the US. I know I'm talking about the US, but it really is the driver of the oil business, oil and gas business these days. Much longer laterals, 10,000 feet laterals are standard these days. Steering is just completely standard. 32 wells in a pad is pretty much standard fare, certainly in the Permian Basin and the Eagle Ford. Drilling times, as you know, 22-day, 24-day wells 5 years ago, now taking 7, maybe 8 days. 100-stage fracs are not uncommon, 70 to 100-stage fracs, and 1,000 tonnes of proppant per well are not uncommon. So you can see if you've got 32 wells on a pad and you're putting 1,000 tonnes into those babies, there's an awful lot of trucks coming and going. In terms of the service companies, we all know that Halliburton, Baker, and all of these kinds of takeovers have been rather fraught. GE writing off $9 billion on Baker just recently. So they really haven't recovered from the 2008 hit, especially from the seismic end of things. So a lot of things happening in the periphery of our industry. And of course, the big crew change, you're all aware of this. This is a certified petroleum geologist, of which I'm one, and so there's not many up here. You've got to be 20 years and a master's, I think, so it's a little bit skewed on the low end of the age scale, but a lot of the discoveries made in the last 30 years have been the responsibility of these kinds of folks, and they're all leaving the industry. And the SPE or AEPG profile would, as most of you know, would look much the same. So how we transfer that knowledge, obviously, is one of the concerns, and one I think, from what I hear, is being fairly well addressed by most of the majors in this part of the world. So let's now look at climate change and how that's impacting our industry. And it's impacting it in a bunch of ways. Things like the Norwegian Wealth Fund, which of course has accumulated all of those dollars and whatever the Norwegian currency is. Krona, of course it is, yeah. Oh, just a trick question. And they've accumulated that by production of oil and gas, and they're now saying they're going to withdraw any support for companies that produce oil and gas. It's kind of bizarre, but that's the way the world is. We're seeing a little bit of reduction in demand for oil and gas. I'll talk about that in a little bit. Not as much as perhaps you would see in the press. Preference, you can read as quick as I can. And all of these kinds of aspects. So on the left-hand slide, it's chopped off, unfortunately, from the screen, is the scale is not very visible, but so this is like 70% and this is 60%, so it's not quite as dramatic as it may look. I couldn't find a more recent graph, so this is fossil fuel share of energy investment, and you can see it kind of fell off a cliff and recovered. From what I understand, and it's hard to find figures that are up to date, there's been a little bit of a recovery, but there has been an awful lot of money, as you would know, invested in wind farms and large-scale solar, certainly in Europe and in this country in the last 5 or 7 years. And a lot of money has been diverted from oil and gas into these renewable exercises. So the wonderful BP outlook, which has proved very reliable and very robust over the years, their projections, again, have proved pretty reliable. We're going to see a reduction in liquid production, basically being overtaken by gas in the next 20 years as share of primary energy production. Coal worldwide stays about the same, in spite of what you would read in every or see in the TV or whatever. And renewables as a total share of primary energy production worldwide, grow up to about 10% in 2035 or thereabouts. So we do see changes, but perhaps not as rapidly as... obviously, if you made this graph for South Australia or whatever, it would look a lot more dramatic. So let's look at, from just the scientist's point of view, a little bit about the story of climate change. Nigel, can we get the whole image on the screen, or not possible?
Probably without. No, let me try one thing.
So anyway, I'll just carry on waffling. And this is going back since little beasties developed hard parts, about 600 million years. And this is the Earth's temperature. We can see it's remained almost stable over those 600 million years, apart from these four major glacial periods. And this is our old friend carbon dioxide. The error bars are probably not madly obvious shown here. They obviously get larger as we go back in time. But we had an awful lot of carbon dioxide in the atmosphere. It was soaked up during the huge development of land plants in the Carboniferous and Permian, and when the development of evolution of fungi and so on in the late Permo-Triassic, a lot of that was remobilised. So we're seeing carbon dioxide in very general terms, more or less the lowest it's been, apart from the Permo-Carboniferous in geological time. So, and there's an obvious, in the very large scale of things, there's no obvious correlation between the two, kind of stating the obvious. You're not very much interested in, we'll take questions at the end, if you don't mind.
This is a suggestion. If you get out of 5.4, the stream might let me just see if I can change the source on it. But never stopped on that.
You carry on. Most of them are pretty readable. So now we're homing in a little bit just on 400,000 years, just a click of your fingers in geological time. And now we're in this major glacial period of the last 2.5 million years. And of course, look at the scale here. We're seeing huge variations in temperature. You all know this. And so we're seeing very rapid rises of temperature. This is before man was on having any role, of course. And then in a somewhat cyclic way, a decrease of substantial number of degrees, 8 to 10 degrees, development of huge ice caps, certainly in the northern hemisphere, and then the repetition of the same cycle. Carbon dioxide, again, you can see the scale more or less. So this is 200 and this is 300. Follows this pattern very nicely. It's almost an overlay. I'm not sure that's what we're looking for, but it's so this is shown by Al Gore and others many, many times. What they don't tend to point out is that there's a lag of 800 to 1,000 years of the carbon dioxide to temperature increase. So the carbon dioxide is a response to natural climate change, and as the oceans warm, then some of that gas obviously bubbles out, and we see an increase in carbon dioxide. Occasionally, we have a large volcanic eruption, and we see that in dust in these ice cores. There's hundreds of these ice cores now from Greenland, northern Russia, and in Antarctica. There's 3 projects at the moment to try and extend these back to 1 million years, one of which has been run by our friends, the CSIRO, and the Antarctic Expedition. So we can look at these various natural cyclic trends as being the kind of swell on the ocean, and where a couple of these intersect, we obviously get a larger impact, and they can negate each other when they don't, and superimposed with smaller scale waves, if you will. So it's not a simple one aspect is modifying it. There's a number. I don't have time, and you probably don't have the interest to go and look at all of these cycles, but one we'll look at is the obvious 112,000 odd year cycle, and then we'll look at some of these shorter cycles, which again are repeated in the geological record. And we know that geologists have been using these cycles, for at least 70 years. Vale from Exxon and Ward Abbott from Shell and then Occidental published this stuff. The famous John was Memoir 21 or something, seismic stratigraphy back in the 60s. So we've known about these kinds of cycles and the timing of them. And Mr. Milenkovic, of course, this Serbian geophysicist, kind of documented these in the 1920s, and his work was only really rediscovered in the late 50s. So, as I say, there's this repetition, obviously, within these glacial periods of the 112,000-year cycle. And it has a big impact on us, of course. These great human migrations have gone on during these very cold periods. We've had massive ice caps of 2 and 3 kilometres over all of North America and Northern Europe. And, of course, sea level has been as low as 120 metres below the present. So people have been able to migrate where it would not now be possible. In our own case, we see that Timor, 63,000 years ago, was visible from the Kimberley and vice versa. So how people are still got across this 120-kilometre gap, we still don't know, of course, but it certainly wouldn't be possible today with the water levels 120 metres higher and 450 kilometres of ocean to traverse. And similarly, of course, the land bridge from Asia into uninhabited North and South America just about 18,000 years ago. So it's obviously the sea levels have had a huge impact on the way people have moved from one continent to the other. So what causes these 112,000-year cycles? Well, we tend to think in schoolboy terms of our Earth whizzing around the sun in a very circular orbit. That would be the case if we didn't probably have the other major planets within our solar system. And in fact, it's a very elliptical orbit, and especially Jupiter impacts that cycle so that we get this repetition of the elliptical further and closer and further from the sun. Similarly, we tend to think that our Earth is sitting at 23.5 degrees to the solar plane, and it ain't necessarily so. That between 23 and occasionally it's 41,000, we get the oscillation of this top of a couple of degrees. And so these are things that we kind of know about, and they obviously are impacting those variations in a natural way. All very well, you'd say, but I'm much more interested in here and now and the close history. So we're not looking at geology now, we're looking at written records. So we can throw our geology book away and start to read the history of the Roman period. We know the Romans were kind of raping and pillaging in their little leather skirts, and that was about all. And that's the soldiers, actually. So the Roman warm period. Then we had the medieval warm period. It was possible to grow grapes very successfully in southern Scotland in these periods. We've had the Little Ice Age, which is only finished in 1850. I mean, this is not very long ago. And then went into the modern warm period. So this is the reality of lived history just in the last couple of thousand years. And it's extremely well documented. The Thames and the Bosphorus in many years froze over, and substantial buildings were built on that thick ice year after year. And places like, that's in the Little Ice Age. In the medieval warm period, as I say, Scotland was very prosperous and grew grapes, as did places like Greenland, which of course are not possible to do much on even today. So this is history. This is not something that's made up. So you say, well, that's all very interesting, but let's look at the near term. So from the early 70s, we've got satellite data, which is less influenced by buildings and roads and all of that kind of stuff, and the manifestations of terrestrial temperature measurements. So we can see, and all of this stuff is referenced from my talk, it's just all public domain. So we can see from the 70s the average Earth's temperature has increased. It's about 1/4 of a degree. And you can see it's spiky in places, but that's just the way things are. So if one of you would pop down the back and change the thermometer by 1/4 of a degree, I don't think many of you would really notice it. So there has been a little bit of warming. We're coming out of the of the Little Ice Age still. It's only 150 years ago, and it would not be unreasonable that we see a little bit of warming still. Whether there's some man-made impact on that, well, that's perhaps the whole part of this rather emotive debate that we see played out on TV and social media on a daily basis. If we look at the longest terrestrial records available, this is in a churchyard in southern England. These are uncalibrated thermometers up until about here somewhere. I can't remember when. But we see some things that we have no idea what caused them. In 1740, there was no volcanic activity. This killed about 20% of Ireland in a single year. But there hasn't been, it would seem to me, any significant trend, maybe a little bit of warming in more recent times. This is the satellite. I'm sorry, it's chopped off at the bottom. Don't know why that's happened. This is just from 1978 to present. But this is Australia. Again, maybe you can see a little bit of a warming trend, but yeah, it's pretty vague. And we see, again, history is replicated in the geological and climate history. If you're Napoleon and you would have been able to look at this graph before you decided to invade Russia, you would have said, it ain't a good year. It's going to be a bit chilly there for my boys. And not many of them came home, as you know. So I know you're saying, well, that's all very interesting, but I want to look at the smaller scale cycles that are perhaps influencing me and my kids and grandkids and so on. And one way we can do that in a simplistic way is people have been looking at the sun and burning out their irises for many years and counting sunspots, and the numbers are a little bit hard to read. This is 50 and this is 400. So we can see that these are black spots on the surface of the sun, and they represent major outpourings of very hot gas, and they influence basically cloud development within our atmosphere when they hit our little planet. Now we can see that this is not a kind of straight line trend, that we're cycle 25 that was just coming into has even less sunspots than we had in 24. This was the kind of modern warm period, and we see that these numbers are decreasing one more time. This was a period of very cold weather, as I just showed you, that was represented in sunspots with very, very low numbers. Didn't say that very well, but you get the idea. So this is an interesting graph where this is terrestrial data, but it's only from the terrestrial stations that have not moved physically, are not in a town, so the buildings and so on don't impact, and they remain in exactly the same place for 100 years. It's in America. And we know that the maximum temperatures in the last 100 years all around the world were in the 1930s. That's true in this country as well. And if you look at the red line, which I didn't put in there, this is just the moving average. In general terms, the trend has been down and pretty flat, perhaps in the last 20-odd years. So these are the terrestrial records. And in the last year, I've got friends in Toronto. They're having an awful time of it at the moment. We just drilled a well in Wyoming. Man, it's been cold up there this year. But that's and this is often record colds and so on. So going back to the initial graph that I showed you, we're on this upper swell of the last 12,000 years, and from this very sharp increase, we're looking at this little tiny period where temperatures fluctuate in a minor way. Again, the scale of this fellow is hidden for some reason. This is like 0.2 of a degree or something. It's 0.5 a degree from there to here. So we're not looking at very much variation compared with these major cycles, whether they're over 50,000 years or more. So I hear you say, well, that McGann cloud is up there, and he's waffling on that a lot of this variation in climate is kind of natural, and yet 97% of scientists think that it's man-made. Actually, if you look at geoscientists and engineers, the numbers are a lot less. But let's look at the paper that is almost always quoted for that 97%. This is a paper by Cook and others from Cook University in Queensland. This is one of the diagrams from that paper, just taken as it was presented. So they looked at about 12,000 abstracts, and they rated them as having no position on man-made global warming, having a position or endorsing it, or rejecting man-made global warming, full stop. This is the 3% down here. And then of these ones, they rated them whether they had no significant impact from carbon dioxide up to explicitly citing carbon dioxide as the main factor in man-made global warming. So of these ones, just stay with me, which were 33% of the total, 22%, I think it was, said that we think carbon dioxide is explicitly cited as the main factor in man-made global warming. So from my maths, the number that explicitly say out of this 100%, whoops, got carried away there, that carbon dioxide is the main factor of global warming is really about 7%. And yet we're always quoted politicians and so on. So dig up the paper yourself. You can read it, but this is what it says. But this is what it's quoted. Two quite different things. And it's kind of interesting that the number, it's a little bit dated now, the paper, but it's still the one that's quoted, the number of people citing anthropogenic global warming was decreasing over time. So let's look at these models that are presented to us in a summary way on a daily basis. And from the 20,000 people that gathered in Spain just recently, I'm sure a lot of them were playing with these models as they sat down for lunch. So we have now really good satellite data. This is the green of the upper atmosphere and what it's doing. We have high-altitude balloons which are let off in Australia and many other places on a daily or weekly basis, and they correlate very nicely. And this is actually what the models are projecting. They're not predicting, they're not predictions, but they're projections based on a whole bunch of equations. And if you really want to look at a bit more data, this is what they actually look like. This is the average that I've just shown you. And none of them are recalibrated to the actual data. I mean, a lot of you would probably work on developing reservoir simulation models of your various oil and gas fields. And if this was your actual production profile over the last 20 years or whatever, and this was your model, I don't think you'd be in employment for very long. But this is what we see in this crazy world of billions of dollars. This is, with due respect to our friends from CSIRO here, an awful lot of CSIRO's budget, and it's $30 to $50 billion worldwide, probably a whole lot more. And they're just not recalibrated to the real world. So I'm not going to ramble on for too much longer. But just a few other things that maybe your kids or grandkids don't get taught in school. That, of course, carbon dioxide is not the major greenhouse gas. Water vapor is. These models are really built around the water vapor. The CO2 is just the catalyst and the trigger, really. I've done courses at University of Chicago on this thing. And it's also, again, the kids probably are not told, it has effectively a logarithmic impact as a greenhouse gas. This is CO2. And so the first 20 parts per million, really important as a greenhouse gas. The next 400 parts per million have the same impact as a greenhouse gas. So, I mean, this is another way of showing the same data. Really important, less important the more we add. So the CO2 effectively saturates as a greenhouse gas. The more you add, it's not a linear relationship. How many of you would have been... Raise your hands if you're aware of that from the audience. Probably not, no. This is basic chemistry. You can find any chemistry book if you know where to look. So just a few more points before I wrap up. Again, is the sea level rising? These scales are annoying, but these are millimetres here. And so here's 0 and here's 4. So these are the GRACE satellites, so US satellites that basically measure wave height. And from the wave height data, as a sailor, and Mike will attest to this, we know that sea kind of bounces up and down. So to get an average sea level from all of that data obviously means jumping through some hoops. I don't know if this is absolutely correct. I've seen this and I can't validate it from the GRACE data, that this is the basic data and this is the, after they smooth out, if you like, all of the waves. And then the University of Colorado and others say, well, from this base data, we know that this is the actual sea level. And so this is what we see presented. Again, it's in millimetres. They're very small increments when you look at the extent of the ocean. The lived experience in stable areas that haven't been covered with a whole bunch of ice, like Northern Europe, and are now rebounding, you can't really measure sea level from the Earth. In places like Sydney, we see perhaps 3 or 4 centimetres over 100 years. This Fort Denison measurement of the sea level has been there in exactly the same place for 100 years. And that is measuring the sea level of the Pacific. So there is, ice is still melting from coming out of the Little Ice Age, but it ain't that dramatic, it would seem to me, one man's view. So why all this kind of hysteria? This is really Al Gore's graph that he still shows, and Michael Mann, who was one of the initial proponents, and this was calibrated from some tree rings in the Sierra Nevadas in California, and this was the impact of in recent times of mankind. The error bars were added somewhat later, and this is what's still shown in schools all around this country on an hourly basis, or perhaps even more than that. It's not a great slide, but this is the reality. We know this from all of the data and history that the Little Ice Age, as I've mentioned a few times, only really finished in the 1850s, and that's when our glaciers started to retreat, and the medieval warm period was here. So this graph of a wonderful, linear, stable, near-term environment in the last 2,000-odd years suddenly turned topsy-turvy because of carbon dioxide is kind of not really honouring what we really know to be the truth as a geologist or as just an interested observer. So I hope in the last I've kind of told you a little bit about the world of oil and how even though the Saudis, still the second largest producer in the world, have been attacked 10 times in the last 5 months by their mortal enemy, the Iranians. No one seems to care. It hasn't pushed up oil prices, and they're the only ones who have any excess capacity. We've seen what's happening in the US with LNG coming on big time from nothing 3 years ago to an awful lot now. I've talked a little bit about reservoir evaluation and what's happening with the service companies. And I've talked a little bit about climate change and hopefully how that impacts some of our business and perhaps business decisions in the coming period. So I guess we're open to take questions. Wesley, are we?
Yes. Yes. Thank you very much, Jerry. So we're open to questions, but if I can just jump in and ask the first question I prepared earlier. So, Jerry, even though the natural cycles appear to play a significant role determining climate patterns on the Earth, and the general consensus that we hear in the media is that the Earth's CO2 concentration at 0.04%, 3% of which IPCC says is man-made emissions, and 1.3% of that again is the contribution from Australia. Is it that man-made CO2 emissions is the overwhelming cause of climate change on the Earth? This is what we hear. My question is CO2 must be an extremely powerful and toxic molecule that can control the Earth's surface, or do you think this is pretty much the greatest scientific hoax in the history of mankind?
Well, I'm not here to talk about hoaxes and so on, but I think you can perhaps, come to your own conclusions from. I started to look at these things when I saw how reservoir simulations often didn't work, looking at relatively simple oil fields where you had the porosity and the hydrocarbon saturation constrained. And if you can't calibrate something as simple as that, how are you going to be able to calibrate something as complex as the Earth's climate? So, and we see that these things are not recalibrated to the reality, so the model. So I'm not here to talk about emotive words like hoax and so on, but I think you can probably draw your own conclusions. Any other questions? Martin?
Yeah. Can everybody hear me? The one graph you didn't put up, which is probably I hate to use the term, but the elephant in the room, is human population over time. And fundamentally, we're a coastal species. So even tiny changes in sea level actually are going to have profound effects on us. They already are. So I wonder if you've got any comments on that.
The IPCC report in many chapters, it's about 2,000 pages, is very well written. And the part on the Pacific Islands, for example, is quite well put together. And there's some data in there that shows that, first of all, they acknowledge that the database was very poor. And then they go on and talk about the islands that they've been able to obviously map since we've had satellite data. And only 2 of the islands out of there's a graph in there that shows about 40 have actually shrunk. So the others have actually got larger. So that doesn't specifically answer your question, but they're the ones that are always kind of held out. And many of those, the few that have shrunk, are on a volcanic plug, which are often quite dynamic. It's a reef development over an active or a semi-active volcano. So some of the things that you might have heard about the Pacific Islands all disappearing isn't actually confirmed by the IPCC report. Now, in summary, which is the only thing most people read, I think it does say that they're shrinking, but that's not what it says in the substantial chapter 25, if you ever want to go and look at it.
But they seem to think their hopes are disappearing. And if you don't want to talk to them, talk to these people with their multi-million-dollar mansions that washed into the sea off Sydney a couple of years ago. It's all very well just looking at a number, it's sea level rise, but you have to combine that with topography, really, and if what you're left with, is that still suitable for people to live in, or are we actually heading for some sort of population catastrophe?
There's probably some places where you shouldn't have built in the first place, I suspect. Yep. Any other?
Thanks, Jerry, for a great wide-ranging topical talk. The definition of scientists being 96% of those that believe in global warming, compared to what was it, 30% or 26% of
7%,
of geoscientists, and again, a similar number for meteorologists. So on a weighted mean average, you think that the geoscientists and the meteorologists are those who would know what's going on in compared to scientists. So my question is, who are these scientists who are so frequently quoted as to having such an overwhelming understanding of what we've just discussed?
Oh, I mean, what's a climate scientist? I mean, a geologist is really... We're the custodians of historic climate data. That's not normally acknowledged. So, I mean, climate science didn't exist in a university context probably even 10 years ago. So what's a climate scientist? I don't know, really. These days it tends to be someone who plays with a computer model and comes up with a projection of what the climate will do. And an awful lot of people are doing that and making a very nice living out of it. So, I don't profess to have any great insight into that. Yeah.
There's one thing we can agree on here. It's a crazy world, whether we're looking at the way we manage our oil and gas reserves or the way we handle climate change and nature. But I'm thinking we put a $10 fee on every barrel of oil or equivalent and put that in the World Bank and then help communities that are in this crazy world to recover. And nobody would hardly notice the $10 fee in their daily activities.
Except they wouldn't get elected, I think. Re-elected, yeah. Certainly in the States, yeah.
So do you think there's an end game in this crazy discussion?
Oh, I think it's a lost cause, Mike, yeah. I mean, but I think as a scientist and hopefully a moral person, if anyone can say the stuff McGann has shown here today is incorrect or malicious or false or whatever, let them say it. But I've given talks on this kind of theme to many different groups, and I've never had that comment. So, but I think it's a lost cause. I mean, but I think one has a moral right to say what you believe. I mean, we are spending in this country billions of dollars to avert a problem that I see. I might be wrong. I'm happy to be proved wrong. I think it doesn't exist. And diverting that from hospitals and schools and real things and real people, there's poor people in this country that could benefit from those funds that are being spent on whatever.
That's what I was alluding to. I mean, the thing is that there's a lot of energy, a lot of money being spent on this without really a huge amount of justification. And as we all know, building models, if you don't adjust your model to match additional information, then you're just wasting electrons.
I couldn't agree more, yeah. And South Australia has basically the highest energy prices in the world, higher than Germany or Denmark at the moment. And poor people who are not heating their homes, they're not cooling their homes because they can't afford, and people will die. They already are. So this kind of crazy world, or the response to this so-called problem, is literally killing people, old people, so very young people. So it's not just trivia. It's a moral kind of fight, but it's a lost cause as I see it. So it's just one of those things. Yeah.
Hi, Jerry. Very good summary of all of that stuff. By the way, in geology at Curtin, anyway, they get most of exactly what you've just shown. But my question is, getting back to the price of oil and gas, it's probably an unfair question, but where do you think that is going? It doesn't look like it is stable enough to stay the way it is at the moment, but what do you think?
In terms of production or price?
Well, you would expect that the price would turn around and go back up, right? Provided the Saudis don't open up everything.
Well, I've never been very good with money, and if I could predict what the price of oil would do, I'd probably be able to make a little bit. But the US is still the price fixer at the moment. The OPEC are not really. They've just cut production quotas back by another 500,000 barrels a day this last week, and which will just make the Americans happier. So it's really hard to tell. I mean,
you just think the US will keep drilling wells at those low costs to keep the price as it is?
well, they're not. They're driven by profit, and all of the smaller companies in the Permian Basin and so on are basically being gobbled up by the big boys now, and so who're in the long game really, and so for them it's all about reserve replacement and ease of saying, we've got 5,000 locations we can drill in the next 30 years or whatever, and so a lot of at-risk money has really got out of the oil and gas business because they haven't got the returns from the unconventionals at $50 oil. So where that all leads us to, it's very hard to predict. Things can change quite quickly. But some of the states, like New Mexico, which has a good chunk of the western part of the Permian Basin, this huge big 40 or 50 billion barrel basin, it's already produced, 26. A lot of those guys are very green, and they might start to put huge restrictions on drilling and setbacks and so on. So things like that can have an impact. If Trump does not get re-elected, we'll see a massive green change back to Obama days, and that will put the brakes on the US. So especially if someone like Warren got elected, but it's highly unlikely, but it could happen. So meanwhile, Russia's sitting in the background, and they're producing oil for different reasons. They're not so worried about the price; they're worried about the import, the exchange dollars coming in over the border. Any more questions?
Australia is importing about 93% of its liquids. If it converted its current vehicles using local tradesmen and stuff to electric and LNG or whatever gas, it wouldn't have to import the oil, and then that would give a lot more employment to the community, plus innovation to build renewable energies and that to help support our transport process. Wouldn't it make us a better country?
I think it's a really good comment, and I'm surprised that the political parties and so on don't see it that way. But have any of you actually seen that simple graph? Oil and production, and the data's there for everyone to see, but it's never in any press report or anything else. And no one seems to be aware that it's our biggest import, and in the last 10 years.
So this is a comment. In Norway, the prolific and historical oil producer, their transportation system, as I understand in Norway, 50% of their vehicles are now battery powered, as opposed to traditional combustion. So to answer that question, it's already happening, and that's happening in a country like Norway.
Huge subsidies in Norway because they could afford it, and they've only got 1 million people. So, it's... 1 million people in Oslo, I guess. But not so many. Not so many people by comparison. So.
I think we could have lots more questions. If we can take one more,
Okay.
and then we'll call it a day.
Oh, thank you very much for being the last one. It's not so much a question. Jerry, you and I have discussed this thing so often. Unfortunately, you think the horse has bolted, and in a general sense, you're probably right. I find that I give this sort of presentations to many Rotary clubs like you do. And invariably, if you have an audience of 30 people, there are 28 that come to me and said, that's exactly what I believe. So I don't think that entirely the conversation is lost, because hopefully they talk to their kids and their grandkids. The main danger about people, press, politicians believing that man-made CO2 is the cause for climate change is that they therefore also believe that it can be stopped. And that, of course, we'll have to wait the 3,000 years you're talking about, looking back, and we can say we were right. Anyhow, that's not much of a consolation to you. Thank you for your discussion.
Yeah, thank you. Yeah.
Okay. Thanks, Jerry.
Okay.